Hi, welcome. If you're watching this video, then you are interested in learning about the basics of force diagrams. So let's get to it. First thing we're going to do is go through the 5 different forces that we need to know for our level and how to diagram them. So that we're going to start with tension. Now, tension, or the force of tension, has a variable capital F with a little t there. This represents any pulling force. So typically we would have strings, cables, ropes, etc. that are attached to an object and pulling it. We can have a hook that is going to pull on it, and I can literally just grab something and I can just pull on it, and that would all be examples of tension forces. So with all these forces, except for gravity, we're going to draw them from a point of contact because they all require points of contact. So at tension, we're going to draw our arrow from a point of contact, and it's going to point away along that string, rope, arm, whatever it may be. For example, if we have a block that is hanging from a string, we would draw our tension like this. A block that's pulled by a string or a hook or arm would draw like this. And again, if we had some kind of a string, arm, hook, something that's pulling it at an angle, it would look like that. Notice that they're all drawn from the point of contact with the block along the string, cord, rope, cable, etc. Our second of 5 forces then is going to be, instead of a pull, we have a push, right? So this push is typically, in a technical way, referred to as an applied force, but we can also just call it push. It's really doesn't matter either way. And this, like the tension force, is going to start at the point of contact and point away from that point of contact. So if you look here at Jim and Scott, who are former students of mine from way back in the day, they're pushing a car that is in neutral to try and get it to move. And so I can be looking at, let's take Scott for example, or I can be looking at the car, and we want to be thinking, if there's a point of contact where the hands are touching the car, then which way would we draw the push arrow for Jim, and which way would we draw the push for the car? So you can pause here and think about this for a second. Great. So then what we'd be looking at is Jim is not going to get pulled to the right by the car, right? The contact there is going to push against his hands. It's the car that's going to get pushed to the right from Jim. So you got to think about which arrow based on which object. So the push on the car is going to be to the right from Jim. The push on Jim is going to be to the left. The third one is going to be the force of gravity. We'll talk a lot more about how force of gravity is equal to mass times this gravitational field strength. For now, we don't have to worry about that, but I wanted to put it here so it's in our notes for when we talk about this here shortly. But gravity is pretty straightforward. We know that gravity is Earth's pull down. So the arrow is going to begin at the object's center point because there's not contact that's required for Earth to pull on us. And that force is going to point downward toward the center of the Earth. I put also here that force gravity in colloquial terms, or what we refer to it as, is typically weight. So force of gravity and weight are synonyms. The fourth of our 5 forces we're going to look at is normal force. So we would use a capital F with the lowercase n, and this represents a surface that's pushing on us. So like the ground or wall or the ceiling, if whatever we're touching that's a surface, we could say then the surface's push is normal force. It's always going to be perpendicular to the surface, and that is why we have the term normal. It doesn't mean common, ordinary, or typical. Normal in this case is a math term that means it's a line or axis that is perpendicular to a surface or a curve. So let's take a look at what we mean. So on this curve, that red line would be perpendicular to the curve. So we call that line a normal line. If there's a two-dimensional plane, then a line that passes perpendicularly through that, we would call a normal line. So you see there's N1, N2 for normal line 1, normal line 2. If we had some, this is used in solar panels, for example, where if we have a solar ray that's coming in at an angle, then we measure that angle from the normal line. So that's how we know to always measure our angles. So that's an example of a normal line. And this can also be a sphere for some reason, right? Like Earth. And so if we were standing on planet Earth at some point, our normal force is going to point perpendicularly away or through the surface of Earth. So for us, this represents contact with a surface. So if you draw a point of contact and that point of contact is with the surface, then you're going to have normal force. This arrow is always going to point from that point of contact directly away from the surface, which is along what we would refer to in math as a normal line. So for example, if we have a flat surface and this object's on it, we have a point of contact right there with the surface, the normal force is going to point perpendicularly away. If it's a tilted surface like a ramp, then from our point of contact, has to point perpendicularly away. What if there's two surfaces? Then we have 2 points of contact, and then we have 2 different normal forces, which we can draw out as being Fn1 and Fn2, meaning normal force 1 and normal force 2. And our last force is the force of friction, which is also a surface force, but instead of perpendicular to it, friction acts along the surface or parallel to the surface. Now, the main thing we want to know for friction is it's not opposite the way it's moving. It's more specifically, it always points opposite the way it is sliding, if there's sliding going on, or opposite the way it would slide if it's not sliding. That means there's 2 different versions of friction. We have the not sliding version, which is referred to as static friction. So we do friction with a little f and then s for static. Or we have when it's sliding, which we would refer to as kinetic friction. Kinetic means moving. So we would put a K there for kinetic. Static is the one that's trickier for students because it's not actually sliding. So you have to think about which way would it slide if the surface were super slippery, and then the friction will go against the way it would slide. So some common examples I see from students that we want to just make sure we look at is which way would the forces point, and we have a couple different variations here. So let's look at A. So one common student mistake that we see here is that they'll draw normal force and gravity like this. So is this right? No, it's not right because gravity should be straight down, right? So let's try B. Gravity straight down, normal force is up. Is this right? No, because normal force isn't perpendicular to the ramp, right? So the correct way to do this would be to make sure that the normal force is always perpendicular, as we know, that's our always true rule for normal force, and that force of gravity is always straight down towards the center of the earth. So these are common student mistakes, and we should have had then the correct version of that right there. So we need to get a bunch more practice, but I want to thank you for watching, and now let's go get them.